Every time a massive airplane lands, something unbelievable happens in just a few seconds. A machine weighing more than 300 tons crashes onto the runway at nearly 250 kilometers per hour. The tires hit the ground so hard that smoke instantly explodes from them. The rubber suddenly goes from zero rotation to spinning thousands of times per minute in less than a second. And somehow, they still don't burst. Most people think airplane tires are just bigger car tires. But the truth is much crazier. These tires survive forces so extreme that normal vehicle tires would explode instantly under the same conditions. In this video, you'll discover why airplane tires are almost impossible to destroy, why smoke appears during landing, and what would actually happen if one failed during touchdown. Every single day, millions of passengers trust these tires without even thinking about them. But airplane tires are among the toughest parts of the entire aircraft. They face enormous pressure, extreme heat, and brutal impact every time a plane lands. Yet modern aviation has made tire failures incredibly rare, and the engineering behind that is honestly mind-blowing. To understand why airplane tires don't burst, you first need to understand how violent landing actually is. When a plane approaches the runway, the aircraft may already weigh more than 200 or even 300 tons. But the wheels are not spinning yet. The moment they touch the runway, the tires scrape across the ground while the aircraft is still moving at massive speed. That sudden friction is exactly why you see smoke during landing. For a split second, the rubber skids across the runway before matching the aircraft's speed. Imagine dragging a giant rubber block across concrete at highway speed. The heat and friction created in that moment are enormous. But airplane tires are specially designed to survive it again and again. Unlike car tires, airplane tires are built using multiple reinforced layers inside them. They contain extremely strong materials like nylon, steel, and aramid fibers that help spread the landing force evenly across the tire. The rubber is also much thicker and tougher than normal vehicle tires, so it can handle extreme friction and heat. But here's where it gets crazy. Airplane tires use insanely high air pressure. A normal car tire usually has around 35 psi. Many commercial airplane tires operate at more than 200 pounds per square inch. That massive pressure helps the tire keep its shape during impact. Without it, the tire could collapse under the aircraft's enormous weight. And despite carrying that much pressure, these tires still don't explode because they are tested far beyond normal limits. Before being used on a real aircraft, airplane tires go through brutal testing. Engineers spin them at extreme speeds, overload them with massive weight, and repeatedly slam them onto testing surfaces. If a tire cannot survive those conditions, it never gets approved for flight. But here's another surprising fact. Airlines replace airplane tires much more often than most people think. Some tires may only handle a few hundred landings before replacement. That sounds low until you realize the amount of stress each landing creates. And instead of throwing them away completely, many aircraft tires are retreaded. The old worn rubber is removed and a fresh tread layer is added so the tire can be reused again. But the tire itself is only one part of the system. The landing gear also plays a massive role. Airplanes use powerful shock absorbers called oleostruts that absorb huge amounts of landing energy. Without them, even the strongest tires would struggle to survive repeated impacts. The landing gear spreads the force so the tires do not take the full hit alone. And now comes the craziest part of all. The small patch of rubber touching the runway during landing is sometimes not much bigger than a human hand. Think about that for a second. Hundreds of tons of aircraft weight balanced on tiny areas of rubber moving at enormous speed. It sounds impossible, yet modern engineering makes it happen safely every single day. Because sometimes, the safest machines on Earth hide the craziest engineering secrets.